Well, welcome everybody. I'm honored to be your moderator today for the seminar on the data you document, or the data we love. So this is part of a year-long seminar series, data sharing for the societies. And I'm Joel Silber. I'm the Director of Publishing at the Ecological Society of America. And I think many of you probably know us anyway, so I won't do a big intro on the Ecological Society of America. Obviously, data is also important to us. I think a big feature that we made a big push on in the last year was that in submission to our journals, as part of other journals that follow this suit, we require data availability statements from the authors. Therefore, pushing towards that goal of ensuring that data is available as part of the publications, it's reproducible and a core part of the science that we have. So we very much are vested in all these developments and what you're going to hear from our speakers. So we are also joined by, as part of this federation, AAAS, Science, American Astronomy Society, American Chemical Society, American Geophysical Union, American Meteorological Society, British Ecological Society, Council of Science, Scientific Science Presidents, Federation of American Societies for Experimental Biology, Federation of Associations of Behavioral and Brain Sciences, and the International Union of Pure and Applied Chemistry. So this is very important to understand that this is bigger than just one society, and that sharing data and making it available is a very important part of the reality of science today, and the reproducibility and the key elements of where we want scientific publishing to head. So with that, I'm delighted to introduce our two speakers. Joy Davidson, she's the coordinator, Digital Curation Center. And Eva Méndez, she's an associate professor at the Universidad Carlos III de Madrid. So they will have some very interesting presentations in terms of how they work with data, and I will let them sort of carry off. I think we will have Eva start first, and Joy will follow. I would ask to please keep yourself muted, and please feel free to type questions into the chat box or use your virtual hand raise function, and then we will have plenty of time for questions. And please include your name in your chat so that we can refer to you if you feel comfortable with that. I will let Eva take it off from here.
Okay, thank you very much for your introduction. You should show my slides now.
Yes, we do.
Full screen, right? Because I have two screens.
Yep.
Got it. Okay, thank you very much for the invitation to Sally and to your organization. I think the topic that we are going to address today is pretty interesting for everybody working with data. And I will make an overview of the whole concept of metadata and why it's important to use cool metadata. I will just go deeper what I understand by cool metadata. In general terms, if we think about metadata, we have to think about the data communication. There is a receptor that receives our data, and we are producers of data. So metadata are the data that we produce. We document the information that we give to the users, other users, to make our data useful. And all the way around, when we are the receptors, or where other people, other researchers are the receptor of our data, the metadata are the information, the details that we want about those data to make them reusable and useful. So the point is that it's the simple definition. I remember in the olden times when I started working with metadata that my colleagues, they say that metadata is a clumsy term because it means everything, but it's a very simple definition, data about data. But I will say that my favorite definition is that metadata are those data that they make useful the data. So in general terms, they are different kind of understandings. And the other problem that the concept of metadata has is that we say metadata in general when we refer to metadata records, which is the description of one data set. When we refer to metadata schemas, when we are just referring to a collection of properties and elements that describe things, that describe data, that describe content. And also we talk about metadata when we are also talking about metadata values, which is the schemes that they are providing, the vocabularies to make those metadata more consistent. So this is a clumsy definition, but we have to pin down how to do it. And also, as I told you, metadata helps in the whole data process for the users, for the developers, and also for the organizations. The more metadata we have, the more precise information we can have. In other terms, metadata is like the face of the reporting. Before of the analysis, if you want to analyze data, if you want to preserve data, perhaps you also need metadata, but this is the description part of who, when, where, how, and why. Is the last will paradigm to request the minimum information about your data. But the minimum information about your metadata could be the enemy of the very comprehensive description of your data. To understand it a bit better, this will be your data in a wonderful can, but nobody knows what is there. You can have a fantastic meat, fantastic data there, but nobody knows what is there. So we are improving a bit. If we have minimum metadata, at least we know that we are having mushroom soup, not beans. For example, we have a brand that probably legitimizes the quality of the mushroom soup. And we have at least what we are going to eat, what we are going to do. And then we can have rich structure and cool metadata, which are all the data that they are rich and they have a quality description that can allow us to take decisions. For example, eating or not eating. I might be in a diet and I decide because of the metadata that I will not eat the mushroom soup. This is the value of the metadata, when you can take decisions about using or not your data because of the description. And also this comes in the context. That's why Joy and we are involved in Fair is Fair project, which is a European project that we are trying to address the best way to manage data in the context of the European research data infrastructure, which is called EOSC, European Open Science Cloud. And also all these rules, how to make data fair, findable, accessible, interoperable, and reusable, comes with metadata hand in hand. Because if you look at the principles of findable, accessible, interoperable, and reusable information, we are talking about metadata most of the time. So sometimes they say that people just use FAIR acronym in a very relaxed way, in a very broad way, but to use the FAIR principles in a really particular way, you need to know a lot about metadata, and you need to have rich metadata, and you need cool metadata, because the metadata is in the core of the FAIR principles. Making your data findable includes provisions for metadata. When you create metadata, you need metadata standards, because sometimes you don't have a particular standard in your discipline, and you have to use an agnostic metadata schema. And also you have the data associated with your metadata in the deposit time in your repository or something like that. Joy probably will tell you more practical issues about how to record and document your metadata in your repository level. And also, if you want interoperability, you need also metadata schemes and metadata vocabularies, what we call in FAIR is Fair semantic artifacts, even if I don't like the term. but you need this interoperability level about vocabularies in between. And also there are a bunch of standards that they can describe different kinds of metadata. So I always say that FAIR principles is 80% of metadata and 20% of PIDs. As I discussed with Barry Mons in a conference in the REA, we can negotiate the percentage, but mostly FAIR principles are metadata. And when we talk about FAIR principles, I just want to go far, and I will call about metadata principles, which is what I call cool metadata for open science. And cool metadata for open science is the way that we are going to make rich metadata in the terms that we can take decisions, as we mentioned with the mushroom soup can. We can take decisions for the use, reuse, or doing a new research based on the data sets. And also metadata is not just for publication, and it's also for users, for software, for services, for computing. It's all about the different research outputs. And metadata is not just for description and discovery, it's also for the contextualization. For example, gives you information about the provenance of the data, restrictions, about the reusability, that sometimes the reusability of the data is a question of licensing and rights. So this is the richness of the metadata, not only the description or the chance of findability, but also taking the decisions through them. And metadata must be, of course, cool metadata must be machine understandable as well as human understandable. And also we need to think about management of data. Metadata is relevant for different purposes, like for funding project information. That's why metadata are also so important for organizations, and also to deal with the impact of the whole research cycle. So that's why we must create cool metadata in the same way as Tim Berners-Lee talk about cool URLs. We talk about cool metadata when we think about interoperability, reusability, accessibility of the data. But if we think about the scientific landscape, we can't just have a lot of vertical approaches by discipline. You can have a bucket of physics data and astrophysics, life science data, and within each domain, each vertical domain, there is a collection of metadata that can reach the data in that bucket. But the real challenge thing is when we come up through different fields across domain. This is what I always said, that metadata are like toothbrushes, that everybody thinks that it's a very good idea, but everybody wants to use their own. So that's the problem when we come up to the transversal approach to data sets. And this is the challenge that we are addressing in FAIR is FAIR in terms of metadata, which is going through interdisciplinary research. What happens when we go out of your box, out of your discipline, and is when the Eureka expression happen, when you can match different data from different domains and make a metadata layer that is cross-domain and helps you to interact between different disciplines. For example, in this slide, we are just trying to show what we plan, what we envision in FAIR is FAIR between different big clusters of different domain-specific information. So sometimes the best is an enemy of the good. So sometimes you can think about that the cool metadata are the richer metadata you can provide, but sometimes you have to deny the richness on the benefit of having a minimum content of metadata that probably is what works at the repository level. For example, when we talk about multidisciplinary data repositories, we have to abandon the specificity of the domain and try to create this common metadata layer that will make your metadata and your data usable. So the challenges at this level is, of course, the cross-disciplinary research, the metadata standards, avoiding the toothbrush effect. That's why we are trying to deal with domain agnostic metadata. So we can just use minimum standard for the most of the data sets, because the differences between data sets, between domains, they are incredibly big. So we have to just try to narrow the description in a terms that is just sufficient for a cross-disciplinary, multidisciplinary research. And also we need the metadata or the data catalog integration. And this is also where we have this approach to metadata, minimum sets of metadata. When we think about metadata quality, we have to think not only about the metadata format, the metadata schema, the metadata element set, but also the metadata record and also the metadata vocabulary for the interoperability cross-domain. And when we think about good metadata, we have to also balance that having good and rich metadata is costly, is time consuming, and needs a lot of knowledge. So you have to balance sometimes that good research outcomes, your publications, your data, your research outcomes, that they are really good and you want them to be reused, is what they have to include good metadata. But also sometimes when we think about how costly is research and producing good data, you can think about to describe also the data sets that they don't work. So people don't want to reuse them. For example, if we are thinking on a vaccine for the COVID-19, is as much important to know what it works and what it doesn't, so we don't repeat the same effect. So this is more or less what I have to share with you, which is the big challenge of having cool metadata. And thank you very much for your attention. I'm very happy to just go through the discussion, and looking forward to listen to Joy that will be more practical in this approach. Thank you.
Thank you, Eva. That was fantastic. I guess I would have one follow-on for that. So, there's a lot of complexity here. So maybe I'll get you to answer a single question, which is, how does your average scientist figure out what good metadata is? I mean, it's a complex thing, right? So it's not as simple as, well, I know what my good metadata is. So, maybe Joy will talk a little bit about that, or, do you have a sense of, how does one figure that out?
This is a $1 million question, which is
well,
rich.
Thank you. I'm rich now.
rich metadata for rich people. So that's the point. It's very difficult. You cannot imagine how many times I have heard in my life. I have been working on metadata for the last 20 years, and first in the digital libraries, and now in the digital data sets collection. And every single time I heard people, no, but you don't know. My field is different. My field is super complex. Every single researcher, they feel that their own discipline is what is the most complex thing. So sometimes we have to just get this agreement to think about, which is the minimum, the minimum successful collection.
Well, makes sense. Well, I'm sure we'll have lots of more questions. We'll leave those to the end.
Sure. Thank you.
No problem. Thank you, Eva. Joy, we'll hand it over to you and your exciting wisdom on your side.
Well, hopefully it'll be exciting. We'll see.
Okay,
so thanks for that. I think it was great to hear Eva's talk. She always makes metadata a very engaging topic, which is no mean feat. She's given you the sort of sense of what's happening at the European level and all the work that's going on to try and get cool metadata as she's described it. My talk is going to be a little bit different. It's going to focus more on the sort of practical discussions you might have with researchers in your communities. And this is really about trying to get them to understand what is needed with regards to metadata and why they might want to take a little bit more time to provide more metadata than they actually need to. So the first point I wanted to make is, before getting into actually what metadata we should be capturing. I think the key thing to bear in mind is that the number one message we want to make to all researchers is that they should be depositing their data with a repository. Wherever possible, we would recommend that it's a domain-specific repository because you will get access to the structured and discipline-specific metadata standards that lead to the cool metadata that Eva was talking about. We've pointed here to the list that the AGU has provided. So there's lots of good pointers out there to help you to find a good repository to use. And we would really see a big role for the societies in trying to push researchers to looking for good domain-specific repositories to use as like the number one step that you can do to try and improve the availability of cool metadata. So if you don't have a domain-specific repository, we would then suggest, your next options are obviously the institutional repositories. Most universities now run these, and also generalist repositories like Zenodo and Figshare. So we would always, as I mentioned, recommend going with the domain-specific repository wherever possible. So for the next few minutes, what I thought I would do is just walk you through the process of uploading a data set to a repository. I will be using the example of Zenodo, and this is because that is the repository that we use in Ferris Fair. And apologies for the black box at the bottom of my screen. This is a quirk of my machine, and no matter how I've tried to remove it, it doesn't seem to work. So apologies for that, but the slides will be available afterwards. So I will be walking you through a couple of the upload fields and the kinds of things that you might be entering as research data metadata, and give you a sense of hopefully what kinds of information you might want to collect. So the first thing that you'll notice when you go into Zenodo or most other repositories is that the amount of information you're actually required to provide is fairly minimal. Within the Zenodo fields, there's really only 7 that you have to fill in. And essentially, you could be looking at uploading a data set and having a citable output within about 5 minutes, really, with the amount of information that you have to put in. So it's really not a huge time commitment at this stage. And that's intentional, I think, for most of the repositories. They want to lower the barrier for researchers to make sure that they get content into the repository. So I think there's good reasons for trying to keep it light on the requirements. But as you can see here, the only kinds of things you really have to provide are the upload type, whether it's a publication, data set, poster, or some other type of output, a title, a publication date, the authors, some sort of a description, and something on access rights and licensing. So what I'd like to do for the next few minutes is just to give you hopefully a few key messages, whether you're a researcher yourself and looking to deposit your data, or whether you're looking to try and amplify some messages to the researchers that you're supporting in your societies on why it might be in your best interest to try and go a little bit beyond the minimum that's required. So the first fields I'm going to pick up on, they are actually mandatory, but I thought it was worth coming back to them anyway, because I think you can do the minimum and provide any kind of a basic title here. But I think it's worth talking to researchers and getting them to understand the benefit of coming up with a good title for their data set. With publications, we have no problems. We put lots of time and effort into thinking about good titles for our papers. Quite often that doesn't follow through with the titles for the data sets. So you want something that's going to actually be somewhat explanatory to somebody who finds the data about what they are finding in the repository. So encourage researchers to spend a little bit of time coming up with a good title. The second field here is the description field. And again, this is a mandatory one, but essentially all you have to do is type a couple of words into this box, and that would probably suffice. So you could write maybe 1 sentence and you'd be done. I think the key thing that we're trying to get across here is that there is benefits to spending a little bit more time here and providing a little bit more context about where the data came from, why it's here, some sort of a description that gives people an understanding about what they're finding if they're coming to a repository. And I think one thing you can encourage researchers to think about, if they think that this is going to be an awful lot of extra work, a really good starting point can just be going back to the published paper that maybe this data set underpins and reusing the abstract from that paper. That can be, even in that, just copy and paste can be better than a poor description. So I think it's worth kind of getting people to think about how they might spend a little bit more time here. The next section here is, again, is a mandatory one, which is about authors, and you can just add in the text fields as I've circled. What I'd like to highlight here on this slide is the optional information that you can capture. And this is where you can start to add the sort of structured and machine readable information that Eva was talking about. So in Zenodo and in most other repository platforms now, there's a possibility to link the author to an ORCID ID. And an ORCID ID is a globally unique identifier. It's a numeric string, and it's attached to a particular individual. So it's a persistent identifier for a researcher. And the benefit of having one of these is that it kind of removes any ambiguity. So it means that if there's Joe Smith from the University of Toronto, who is an active researcher in the field of research data management, we can unambiguously identify his works from Joe Smith, who is also a researcher in research data management in Monash University in Australia. So it gives you this kind of nice way to unambiguously link yourself to your outputs. So I think it's also worth mentioning, this is a screenshot from my own ORCID identifier. ORCIDs are freely available to anyone. You can just sign up and start using an ORCID ID right away. But I wanted to flag up the benefits to researchers for using this. It's not just so that you're uniquely identified and you can be unambiguously linked to your outputs. It actually does give you a really nice value-added service. What the system does is it collects all of the work. So if you link your outputs to your ORCID ID, it then gets harvested in automatically back into your profile. So in a nice way, it gives you a sort of instant up-to-date CV or biography anytime you need to use it. And anytime you apply for a grant application or a new post, you'll have to have that. So it does actually kind of yield benefits for you to use this and to keep it up to date. So I would really encourage people, if you don't already have an ORCID, to register and get one and to use it. So that was a little bit on the authors. I think one of the other optional fields that we would encourage people to consider, we're now back into the Zenodo screen share. When you're uploading a record, you have the option to also record information about other contributors, not just those who you would consider to be the authors of the data set. And this is an example from the research data set that I've uploaded into Zenodo. And you can see here that you can add as many contributors as you like. And more importantly, you can see on the right-hand side of the screen, you can start to assign fairly specific roles to what these individuals played in the process of collecting, creating, analyzing, managing, or processing the data. So you can start to really kind of show lots of different actors involved in the research data over the life cycle. And it takes a little bit of time to add this information, but a lot of it's drop-down lists and can be done relatively straightforwardly. I think the key thing to remember here is that it provides that additional context that Eva was mentioning, this whole information about provenance and what's happened to the data, who's been working on it. It gives that nice picture of who's been involved. But I think also for researchers, it's always really good to drive home the message that attribution is really important. And in this new sort of drive towards team science, where we're acknowledging different contributions to research activities, this is a really nice way to start to give that credit to people who might otherwise be a little bit behind the scenes. So if we get into the habit of trying to give credit where credit's due as part of good research practice, but it also helps to foster this team science approach. And I think the other good thing to point out here is that you can include their ORCIDs into the record. So again, it gives them that chance to have their CVs automatically updated as well. Another optional field that I think is quite an important one to include is the funder field. And this is generally something, not everybody's funded to carry out their work, but if you are funded, quite often your funder will have expectations that anything that you produce and share provides due acknowledgement to the fact that funding has been provided to allow this work to happen. So it may be a condition of your grant, and in that case, you should definitely make sure that you're capturing this information. As you can see here in this Zenodo example, we have the opportunity not only to capture the information about the funding body, but also about the actual project that the work is related to as well. And in this Zenodo repository system, they are linked to the OpenAIRE data sets, which allows us to then type in things like grant numbers and other unique IDs so that we can get a very good specific link to the project. And I think that's quite important because I think anybody who's worked on a project before realizes that not everybody will type out the right words for the project title. So using a grant identifier is a really great way to keep that link. But again, it gives you more specific information in a contextual sort of a way about why the data came to be, who paid for it, and allows people to make an informed judgment about its potential reuse value. And it keeps your funders happy, which is always great. A really important additional fields that I would strongly encourage people to consider, even if you're not going to use any of the other fields that we've looked at here today. This one here is where you get the chance to link related outputs to the upload that you're putting into the repository. So when you're uploading your data set, you have the chance to add in as many related identifiers as you like. So what you can see here is that they want to see a DOI. And again, more and more research platforms and repositories will allow you to mint DOIs for various different kinds of outputs, whether it's research data, whether it's software, whether it's publications and the rest. So this is really where you want to have that chance to provide the contextual link hub. And you can see here that you add your DOI, and then you get a chance again from another set of drop-down lists to decide what's the relationship between my data set that I'm uploading now and this related output that I'm trying to bring into the picture. And you can see here from this list that it's quite a lot of options that you can have here. So there is likely going to be something that will fit every need. But it does also kind of go into very kind of subtle things where you can even include things like reviews of the upload. So if there has been a public peer review of the data, then you can link to it as well. So it again just helps you to give a lot more contextual information and to provide end users with some degree of confidence about making an informed choice on the quality and the potential value of the data that they might reuse. So all of that, it's a little bit of extra work, but the very fact that you would put your data into a repository, number one, will give you a citable output. And this again is a Zenodo example from the data set that we've been looking at through the previous screenshots. And as you can see over on the right-hand side, this is a very important value-added feature, I would say. It gives you the way to cite the data set. So anytime I would then want to refer back to my own data set, I get the right way to do it. And more importantly, anybody else coming here to use my data set also knows exactly how it should be cited. And you can see many of the repositories now build in a lot of social media platforms, so you can start to tweet about your work and get more promotion. So that's a really important feature. And even by going with just the minimum metadata and using a repository, you will get this citable output. I think the other good thing about most of these platforms is that you can start to see who's using it. The number of views, the number of downloads. And I think as researchers, it's always quite encouraging for us to see that our research is having some impact. So it's always good to be able to try and track that. So again, the more you put into your records, the more hopefully you'll get out. I think one point also that is worth flagging up to researchers is that not all data sets can be openly shared. in a repository like Zenodo or a domain-specific repository. This is particularly true if you're working with personally sensitive or commercially sensitive data. There may be very good reasons that you can't share it. And I think this is where metadata descriptions really do come into a much more crucial kind of a role. Because even if the data itself can't be shared, the metadata description usually can be. And this is really going to be the primary tool then that you have to promote your work. And what we would encourage people to do when you're uploading your data is so you can make use of all of these repositories as well to describe the research, even if it doesn't lead to a data set being uploaded as well. You don't always have to include the data, but what you could do in your metadata description is provide a real kind of clarity about why the data can't be shared, and more importantly, how you might go about requesting legitimate access. So we would again encourage people, even those people who think they can't share anything, to make sure that they're still putting some time and effort into coming up with a good metadata record. This all leads, hopefully, to better research links. And I think this slide here is just to show a new service that has come out recently from the Open Air service in Europe, and it's called Research Graph. And what it does is it pulls together different identifiers and metadata from lots of different repository and metadata aggregator services. And I think the good thing here is what it does is then makes all of these links visualize. You can visualize how they all link together and start to see that kind of bigger picture of research. So it really kind of adds value to all of the information collected in these various different repository systems. So this is just an example of the Fair is Fair project. So the previous screenshots I showed you about my upload as a researcher working on the Fair is Fair project for my data set. You can see here, if I go into the Research Graph platform and search for Fair is Fair, I can see that they've got 182 publications and 11 data sets that are available. And when I start to scroll through, I do see my own data set listed there. So this has happened automatically. I haven't had to do anything. The system has gone out and pulled in this information and provided it in that context because I completed the funder and the grant information in my Zenodo records. So it just goes to show that a little bit of extra effort on the part of the depositor can really help to promote the findability in numerous different ways for the research outputs that you're working with. So just to sum up, I think hopefully you'll have seen that, yes, a little bit of extra effort might be required to produce good or cool metadata, as Eva's calling it. But hopefully you've been convinced that there are ways to do this and that there's benefits from doing so. So just to sum up in a couple of points here, what we would encourage you to take away either as researchers or as a society who is working with researchers. Number one, encourage researchers to use domain-specific repositories whenever possible. Get them to start thinking about providing basic metadata as early on in the life cycle as possible. It doesn't have to be at the point of deposit. Start thinking about it early, but get them to think about at least providing enough metadata to get a citable output, even for those data that can't be shared openly. Think about the benefits, encourage people to start thinking about what's in it for them and how they might start to be able to make better links and better kind of connections through their research. And finally here, I think it's just worth mentioning that all of this leads to greater visibility of the work, hopefully more citations and greater collaboration opportunities. So hopefully some good reasons there for you to spend a little bit more time and effort on loving your metadata. So I think that's it for me, and we can maybe go back and pick up some questions.
Thank you very much, Joy. That was great. Much appreciated. I guess I'll open it up to questions around the group. There was some discussion on the chat, and I guess we could carry one topic, which seemed to sort of be a bigger one. I think it was Yuhan who asked the question. In terms of, when you're looking at interdisciplinary research and sort of the ability to share data, how complex is that, and what are we really looking at in terms of, you know, the effectiveness of that? Because that's much more involved than, you know, the domain specific metadata sets. Any thoughts on that, Joy? Yeah.
I think it's one of the things we're looking at in the Fair project, and a lot of the hard work is happening at the kind of service provider level at this point. So we're trying to work on the interoperability at the level of the aggregators and the different search engines. But then it also has to be in parallel happening at the grassroots level. So the researchers need to be able to also know what standards to use that will then be most likely to get picked up and pulled into these aggregators. The difficulty now, and I think we've seen it in the chat, is trying to come up with that sort of generic level for the metadata catalog level, so that you at least know that the data lives somewhere. When it comes to the interoperability side, is then working out what kind of standards can be mapped to things like CDI, DDI, CDI, and other standards that are starting to look promising for interoperability. That has to happen at the community level. So we need to see parallel activity happening at both the aggregator level and at the grassroots. So it's not really an easy answer, I don't think. I think it's a work in progress, but it's certainly a lot of people are working on this at the moment in Europe. It's a big topic. And continuing into the Horizon Europe program that's just kicking off.
Right.
So I don't know if you had anything to add to that, Eva. I know this is your area of interest.
No, but I agree with you that I think is sometimes even within the same domain, they have also approaches to interoperability between catalogs. I mean, so imagine when you come to the bigger domain specific fields that you have to go through cross-disciplinary. So I have found working in the PANOSC and the project and in one of the clusters of photon and neutron that they were thinking about the interoperability among the same discipline. So that's challenging.
That's true. It's true. I think a big discussion that's also going on in the chat is this idea of citing of data, and that it's not being effectively cited, correctly cited, and sort of other issues. I mean, what are your thoughts on that? I mean, how do we get people to properly or even cite data as part of their papers or other work? And Shelley might have a thought on this as well.
I mean, I think from my perspective, I think the funders have a big role to play in making the expectations. So in Fair, we've come up with some policy enhancement recommendations, and one of them is that we want to see the same level of requirements on data availability statements as what we're seeing in publications. So we want that to apply to the metadata descriptions for data sets as well. So I think funders can help to drive the change. But more importantly, I think it's the societies, the people that are trusted authoritative resources for the researchers. So if societies can encourage this as part of good practice, I think that would be a really crucial aspect of getting people to actually do it. And I think lastly for me is that just make it easy. I think what we've seen in the Zenodo example is that once you deposit your data, you can get, here's exactly how to cite it. So it's easy, I can cut and paste that. And it's just making sure that people actually do it. So it's getting it into the culture, and I think societies will have a huge role to play in this.
Yeah, it comes up to what is just discussed by Amy in the chat. It's about the incentives. I mean, you make citations because we do science like in 19th century. You need exactly. We need the impact factor. We make citations. For me, nowadays, a citation is just a link. That's it, full stop. But we need a persistent identification. So for me, it will be just a DOI with a link. The citability comes with what I call in open science, the motivators of will. That is the things that the researchers, we have the motivation to do it. And those are three: money, mandatory systems or legal issues, and ranking. And also the fourth, which is the most powerful, is where it is seduction. It's easy, is rewarding. It is fantastic to do it. But if I don't have any motivation to do it, why I will do my data citable, what I will do my data servable. The point is that always the bottleneck of open science and open data is far away than privacy, intellectual property, and all these bottleneck issues in the data sharing, is the lack of incentives. So if you don't have incentives, open science is not going to happen.
Right. So I'm going to ask us something more of an off the wall type of question. So this will be fun. So if you think about the future, right? And I'm assuming that we're all extremely young on this call, so we know exactly what's going on in the minds of young researchers. But if you think forward, 10, 15, 20 years, we're all living in the metaverse. How do we have to think about data availability, the way data is stored, and what a younger generation is going to want to do, given the tools and sort of evolution? Do you have any thoughts on it?
I teach to freshmen, informational skills, and they look pretty concerned about data, personal data, and privacy issues, but it's just in theory. I think it's like, I'm concerned about getting fat, but I keep eating chocolate. You know what I mean? Right. Is that kind of stupid attitude that the young generations have? I'm very concerned, but I don't care. I keep doing. I keep posting personal information, personal pictures, and very kind of. I think we need a lot of literacy, new literacies. Data world are creating new literacies, very needed.
Do you think they'll interact differently with data and have different expectations, given that to them everything is at their fingertips, right? So that the world they've grown up in is the Google search, right? And not even the library. So how does that change the way we have to make data available? And maybe they'll understand it better. I don't know.
Yeah, I think the expectations are there now. I think there is already frustration if you can't get access to the data that you want. And, I think, again, it's hard to know exactly what the future will hold, but if we are looking to have legacy data, what I'd like to see is that hopefully some of the important data sets we have now, the COVID data and all of the, really useful stuff we've collected here, I think will have value well into the future. So the way that's documented and the metadata that's associated with that becomes really, really critical. So I'm hoping that, the stuff we're producing now will be part of this metaverse, and that we will have some backwards compatibility to try and make this stuff useful to researchers in the future. But I do think the expectations are now, and they will continue to grow.
Yeah,
that makes sense. I don't see any hands raised. I'm just trying to make sure that I'm catching people.
But this is a parallel discussion. Yeah. I'm trying to follow you and follow the chat.
I know, so am I.
Super interesting. Yeah.
The chat's talking a little bit about regulations and sort of, I think they were getting into this idea of, you talked about this idea of, what can be available, right? And what is legally available, and how do we determine that? And what will that look like? I guess, I don't know.
Mm-hmm.
Yeah, I think a lot of this is really down to the researchers. So researchers have to understand the context they're working in, the expectations of the funders, the environment they're working in. But ultimately, they're the ones who have to kind of plan for what can be shared and what has to be protected, and to know how to go about doing that. I think we're starting to see more work, especially in the context, as Eva mentioned, of the European Open Science Cloud. They're looking to streamline a lot of this stuff and make a lot of it machine actionable, so that policies and regulations don't necessarily have to be everybody's first and foremost thoughts. Is informed maybe in the platforms that you use, they're governed, and you don't have to think about it. We're not there yet, but I think definitely that is where we have to move towards, to make it as easy as possible for people to know what they're meant to do and what they're not supposed to do.
Yeah, that is hard, especially when you have lots of data repositories. And I think Amy Nuremberg had a question for us. So Amy, if you want to unmute, you can ask your question.
Thank you. I appreciate that. And I just wanted to respond to the point that you had raised around what does the future look like? And I think one of the important things for us to recognize is that the future is now. This is the world that, and I put a quote in chat about that. This is the world of immediate availability and interoperability that researchers expect now in their research methodologies, but we don't have the technology systems, the operational systems, the incentive systems to support the behavior that will allow researchers to interact with data that way, because researchers themselves aren't putting data out into the world in that way. And it's closing that gap between the behavior as a researcher that I'm willing to engage in to make my data available, and yet the odd expectation that I have that everyone else's data should be available to me in this magical way, that I myself haven't invested in producing data in the way to make it available. And I think it's really thinking critically about what are the different aspects of closing that gaps. And I'd be interested to hearing about you. I think, we've talked about legal issues, licensing issues, behavioral issues, citation issues, thinking about how to bring these together to support the researchers in acting in the ways that they hope to take advantage of.
You're right. I mean, it's a very hard nut to crack, because we were on a call with Shelley, actually, with the University of California libraries, and I was surprised that the discussions were and presentations from the libraries were something back to the 1980s, and the idea that sort of the libraries can better support sort of this as part of the overall scheme of where we're heading in the future, and that the incentives are there, just didn't exist. I mean, it was just surprising to me that there isn't greater movement. So yeah, we have quite a road to hoe on this, as someone said in the chat.
I think the point that Amy made about the fact that people have expectations about others' data being available, and it doesn't always translate into, well, I should share mine. I think that is a very difficult thing to crack, and it's whether people don't think their data is important or it's not potentially valuable to anyone. There's lots of different reasons people might have around that. So I think there's work to be done to try and make sure people realize that all data potentially is useful and valuable, but for it to be valuable, it has to be well documented and trustworthy and all the rest of it. But I think, this is a good point. And I think we are all probably a little guilty of expecting more from others than we're willing to do ourselves.
Oh, you're absolutely right.
Yeah.
And the incentives are a good example of this, but they don't exist, right? So tenure is still tenure based on what you've published, not your data sets, or the validity, or that you've made data available, and that is part of a larger community of research. But
I mean, it's interesting. Oh, sorry.
No,
sorry, Eva.
Go ahead.
Yeah. I was just going to say, it's interesting because we have so many people signing up to DORA declaration and like the lead-in manifesto, saying that things will start to change in the way that research assessment is carried out. I think anybody who works in a university knows that's not the case on the ground. It is still the same old ways of approaching, despite the policies and all the good intentions. Until it starts to change on the ground, I don't think we'll see it. And we are seeing some good practice. I can remember even a couple of years ago, some universities in Germany were in their hiring process saying if you weren't demonstrating that you were an open researcher, you wouldn't get the position. So we're starting to see it filter through, but it's so patchy at the moment. So we really need to see this kind of filtering into day-to-day hiring, firing, promotions, and all the rest of it.
And also what I was about saying is something that we have been discussing in FAIR is FAIR and all the open science policies too, is the crucial value of the new early career researchers generations, that they are really keen to apply open science things, but they don't have the skills. So when I was doing my PhD, I didn't know how to do a citation, but it was something that I have to do in my thesis. And now every single research has to have citations and the proper way to do it. So what I'm trying to do in my own university is that the data management plan, the metadata approaches is in a very basic level, comes with the thesis planning. So when you do with your thesis, you keep doing all your research career. So just teach these students to manage data, to share data as a by default situation. Because if not, you have to just let them rise as a senior researcher, and then you have to ask them why you don't share your data. So that's difficult.
That's true. You're right. I'm just following the chat to see if there's any other questions. I think, you know,
But this amazing comments.
Yeah.
I'm just saving the chat to read it later. Amazing.
Yeah, so I mean, yeah, exactly. Comments on tenure, you know, it can't be evaluated because it's not peer evaluated. I mean, you know, but there are roots to this. But again, we're stuck in the way, as you said, the way we did it in the 1800s. And so
absolutely. And
we're still doing that.
Yeah, and the really sad about the thing is that we have the technologies that could make things different. So that's the real sad point.
Exactly. I'll ask Shelley, do we want to put the slide up for the next session? Can we get that? Look at that. I ask and it happens.
Good.
It's amazing how these things.
Your voice is magic.
Exactly. Thanks, John. But yeah, so I'll make a quick plug for our next session, which is on actually December 3rd. And this will actually be with Marcia McNutt. So she was the former editor-in-chief for the Science Family of Journals, and then she is now president of the AAAS. She's actually the first woman to lead the Academy, and she was also the first woman to be editor-in-chief. So I think we'll have an interesting discussion about the reproducibility and open science scholarship, especially from the National Academies perspective, and sort of what they're doing in terms of their efforts and how society is playing. So I think this will be really, really important for us to, you know, both have someone who's just on the sort of, we'll call it the leading edge, and working with organizations around this. I also want to point out it's going to be at a different time. So this will be at 11 a.m. Eastern Standard Time or 1600 UTC. And hopefully by that time, all our clocks are aligned, so we can actually figure out everybody showing up properly. But yeah, please do spread the word, and we'll be happy to have who. And again, I would like to thank Eva and Joy for their wonderful information on Ferris Fair, and really leading us through a very good discussion on metadata and how that plays an important role, you know, in everything that we do.
Thank you.
Wonderful. Shelley, do you have any further
much.
thoughts? Did I miss anything?
Oh, this was absolutely amazing. I saw Seth had his hand up, but I'm wondering, we've got one more minute, and I'm really interested in this concept of data peer review. And I'm wondering, did Ferris Fair think about this? This is like really hard to do, and I'm just wondering if that came up.
That will be for the next project, Joy.
We're not doing anything directly on open peer review, but it is kind of indirectly addressed as one of the kind of other outputs that isn't a publication. So I think as part of a fair ecosystem, it's data, it's reviews, it's all about, you know, making as much of this open and transparent as possible. So not directly, but indirectly.
Yep.
But as Eva said, lots of room for new projects.
Yeah, absolutely. Data peer review, I think, is a very interesting topic that we have to be conscious that we have to be very careful that we don't repeat the same mistakes that they had made the publication system unsustainable in the new reproducibility, in the new amazing production of papers, etc. If we go through the peer review of data, you need to have built up a system of peer review. And for me, the best way of doing peer review is open it up, because
Right.
when you open data, you make a kind of a claim for quality, because your peers, if you just put data that they are not good, in 3 minutes, you will be dislegitimized. But if you do it in the close domain on the peer review, the tacit, you know the producer, you know the reviewer, it becomes the same sheet. Excuse me for the word, on the publications.
Yeah.
I think, yeah,
Totally.
definitely. I mean, I'm seeing lots of things in the chats, you know, about open preprints and registering and data management
Yeah.
plans. We would encourage all of these things to be part of the research ecosystem and a fair ecosystem. So definitely, I think the infrastructure is there, as Eva said. It's just about making that switch to getting people to use it.
Yeah.
And making it possible.
Yeah, and highlighting that, you know, staying away, and I think I saw Amy make a note on this about we don't want to fall into a really inappropriate metrics for evaluating data just because we have access to the old systems. We need to really think about data differently. And
That's true.
And to circle back to the point of our talk today, the really well-documented data is far more valuable and reusable in the future than non-documented data. So that actually contributes to the value and contribution to science, and needs to be part of this. So thank you.
Good job, Shelley.
And on that, I'm going to stop our recording.